Okay, so I want to go over the product rule. This is the rule. If you have two functions that are being multiplied together to take their derivative, you take the derivative of the first function, keep the second one the same, and then take the derivative of the second function and keep the first one the same. So here we're going to call this f and this g. And you could tell it's product rule because there are two x variables in there. And so if we're following the rules, take the derivative of the first. So the derivative of square root of x is 1/2 x to the negative 1/2. Keep this one the same. So it just stays cotangent x. Plus, then take the derivative of the second. So that's going to be negative cosecant squared x. And then keep this one the same. So that one's going to be times the square root of x. That's the derivative. Now, if you're simplifying, it should look like this. So cotangent x over 2 square root of x minus, and then normally you put this in the front. So square root of x cosecant squared x. Right. Again, all right, for the quotient rule, whichever functions in the numerator is what you take the derivative of first. So derivative of the first, and then you keep the second the same. Same thing as the product rule. And then you have to take the derivative of the second, keep the first exactly the same. And then on the bottom is the denominator squared. Excuse my child here. She's just singing in the background. Hopefully you guys can't hear her. Okay. All right, so we have a function in the numerator and a function in the denominator. So we're going to use the quotient rule. So take the derivative of the first one. So that's going to be 300x squared. The bottom stays the same. Minus, take the derivative of the bottom, and the derivative of the bottom is just 1, because the 8 turns into a 0. Keep the top the same. So that one stayed the same. Again, this is our top function's derivative times the second. Takes the denominator's derivative times the first. All over bottom squared. So again, this would be an acceptable answer. But if you're trying to simplify, right, we would want to distribute that out. So 300x cubed minus 2400x squared minus 100x cubed all over x minus 8 squared. And then further, you would cancel out the top, or not cancel, but combine like terms. And then the bottom is x minus 8. Oops. Squared. All right, so the derivative of two functions that are one inside the other, so composed, right, is you take the derivative by starting with the outside function. And so whatever the derivative of the outside is, so f prime, okay, take the derivative of the outside, and you keep the inside exactly the same. Okay. Then you take the derivative of the inside. And that's it. Okay, and so we'll do a simple example right here. Let's call h of x. Okay. And I'll make it kind of easy to see everything. But e to the inside of the function would be 5x squared. Okay. So to take this derivative, right, the derivative of h of x would be h prime of x. The outside function, because this is inside the variable, the outside function is just e. So that's going to stay exactly the same. And to take its derivative, it stays the same. Then we take the derivative of the inside, and the derivative of the inside is 5x squared. So that's going to be 10x. And that is it. All right, here's another example where the 5 is just a coefficient. So actually the 5 you can leave completely on the outside and not worry about it when you're taking the derivative. Here, you normally want to rewrite this if it helps you. so that you can actually see the power on the outside. And so the power is actually the most outside function, and so that's the one you do first. So the 3 drops, and it's going to be 3. The x1 is 3 minus 1, so that's 2. And the inside stays the same. So that's the inside, stays the same. The next part of the function is the cosine, because that square root of x is inside of the cosine. So the derivative of cosine is negative sine. Keep the inside the same. Well, the inside happens to be square root of x. And then the inside of that would be the derivative of square root of x, which is 1/2 square root of x. So the actual end answer is going to be negative 15 over 2 cosine squared x sine squared x all over 2 square root of x. Now these cannot cancel because they're all part of the trig function. So this is your final answer.